In this video, we are looking at line of best fit. That's also called linear regression. So if a scatter plot forms a cluster resembling the pattern of a line, we can use Desmos to find the line y equals mx plus b that best fits that data. So here's an example of a scatter plot. And if we wanted to know the line that goes through that data the best, that would be called the line of best fit. Now that line is the line y equals mx plus b. But we are going to use Desmos to find the m and the b value. So here's the step-by-step of how to do that. In Desmos, the first step is to click the plus button. Then you're going to click Table, and you're going to type in your table values. So the table is given to you as x1 and y1, and you would simply type in your x's and y's. Then step 4 is to type in this formula, which is going to tell you your m and your b value. So you're going to type in y1 squiggle mx1 plus b. This is very important. So that's y1 squiggle mx1 plus b. That's going to give you all of our important information for the line of best fit. First off, you will notice that it gives you an R value. So remember, that's your correlation coefficient. So it should be strong because this is the line of best fit. It also shows you your M and your B value. So we want the equation y equals mx plus b. So we're simply going to take M and plug it in and B and plug it in. That gives us our line of best fit. You'll also notice in Desmos that the graph is given to you. So when you typed in your table of values, it graphed those table of values for you and the line of best fit. This line of best fit is the line y equals 1.2x plus 3.6 because that was the m and b value that was given to us. Let's do some more examples of finding the line of best fit given a table. In example 1, Lisa collected data on the grams of fat and the grams of carbohydrates in 10 sandwiches at a popular restaurant. The table below represents the data she recorded. Which linear equation best fits Lisa's data? First, we're going to go into Desmos and click the plus sign up at the top left, and we're going to add a table. Then we're going to type in all of our x values and all of our y values. Now that we have all of our x and y values in the table, we can click in a new box, and we're going to type y1 squiggle mx1 plus b. Now this gives us an m and a b. So that's what we're going to write down first. So the m that we're given is 0.499. The b that we're given is 23.2285. We could round that to 229. So now what we're going to do is we're going to write y equals mx plus b. So we're going to take our m value and put it in the place of m. So that would give us y equals about 0.5 x plus our b value. And our b value was about 23. And that is where our final equation comes from. So y equals 0.5x plus 23. In example 2, you have a table, but you also have a graph that you can look at. So the graph is going to give you an idea of what the correlation is between the x and y value. But notice that our question is essentially going to ask us for the line of best fit equation. So this table and scatter plot show the price of a barrel of crude oil over 5 years. The variable x presents time in years and y presents the price of the crude oil per barrel in dollars. According to the scatter plot and the table, which equation best represents the relationship between the year and the price of the crude oil? So first we're going to take our table and put it into Desmos, so plus add a table, and then put in your x and y values. Now that we have our table of values, we're going to tell Desmos that we want the equation of the line of best fit, which is y1 squiggle mx1 plus b. And now we have our m and our b value. So m is 9.366, b is 19.48, and we're going to write y equals mx plus b. So we're going to take m and plug it in. Now that rounds up to about 9.4 based on our answer choices. And then plug in the b value, which is about 19. Based on our answer choices, they round it to the 10th place, so that would be 19.5. All right, so our final equation of the line of best fit is y equals 9.4x plus 19.5. In example 3, the table shows the prices a company charges to build fences over various lengths. Write a linear equation for the line of best fit for the total cost y in terms of the length x. So in Desmos, click the plus sign, then add a table, and we'll put in our x and y values. Now that we have our table of values, we're going to tell Desmos we want the line of best fit. y1 squiggle mx1 plus b. So our m, I'm going to write all of this out, and we're going to talk a little bit about rounding in just a moment. So our b value is 44.7067. If I were rounding to the nearest tenth, that would be 1 decimal place. And if that were the case, then our m would be 14.2. Because if I'm looking at the tenths place, that's the first decimal place behind the decimal or to the right of the decimal. If I want to round this number, then I'm going to look at the number behind it, and if this number, 0, if that number were 5 or higher, then it would turn this into a 3. But since this is a 0, we're going to leave this as 2. All right, for our b, if we're rounding to the nearest tenth, then we're going to look at the 7, and we need to decide if that 7 is going to stay or if it needs to go up to an 8. If the number behind it was 5 or more, we would change it to an 8. But since this is 0, it's going to stay 44.7. If you were asked to round to the nearest hundredth, you would have to use 2 decimal places. So that would be 14.2 something. Now that number, in this case, is a 0, but we have to look at the number behind it to see if that's going to bump the 0 up to a 1. Okay, so we're looking at the zeros place, but right behind it is a 4. Since that's not 5 or above, that's going to remain 14.20. Then we have our b value. If we were rounding that to the nearest hundredth, That would be 44.7 what? So in this case, again, we have 7, 0 right here, but the number behind the 0 is a 6. Since that's higher than a 5, this 6 is going to bump the 0 up to a 1. So now, instead of 44.7, it's 44.71, since we were rounding to 2 decimal places. In this case, because we aren't told, I'm going to carry out all 4 decimal places just so that we can be as accurate as possible. So if we're writing this in the form y equals mx plus b, we're going to take our m and plug it in. So that would be y equals 14.2049. And then plug in the b value, which is 44.7067. In example 4, the table shows the scores of 7 students on a math and science test. What is the correlation coefficient for the data? Now in this one, you're not asked to find the line of best fit, you're just asked to find the correlation coefficient. Now remember that your correlation coefficient is also the R value. So you're still going to click the plus sign and put in your table. And once you have all of your values in, double check them just to make sure you haven't made any typos. Then go down and add your line of best fit equation. Now instead of looking at m and b, I'm looking for the correlation coefficient, not the slope, not the y-intercept. Now when you're looking for the r value, be careful because there's also an r squared value. We don't need the r squared value. So our r value here is 0.6312. So as long as you've double checked your table to make sure that you've plugged everything in correctly, then that should be all that we need to do. All right, in example 5, this table shows the arm span and height that 6 vertical jump contestants reached during a track and field competition. So we're going to have to put in our table, type in our formula for the line of best fit, and then look at the R value. Once your data is in the table, you can type in your line of best fit formula. And remember, we're just looking for the strength and the direction. Our correlation coefficient is always between -1 and +1, and 0 is exactly in the middle. The closer you are to 1 or -1, the stronger, so the closer you are to 0, the weaker you are. So our R value in this data set is 0.1225. So we're really looking at that 0.1 number. 0.1 is really close to 0. Now we just have to determine positive or negative. Well, since this is a positive number, that is a positive relationship. If this were a negative 0.1, it would be a negative weak relationship. Finally, before we end this lesson, I want to remind you that if the table has dates or years specifically as the x values, you're going to want to enter 0 as the x value in the table in Desmos instead of the actual year date that's given. So instead of typing 1990 as our x value, we are going to type in x equals 0 as our beginning value instead. Then in 1992, notice that 2 years have passed, so that's going to be an x value of 2. For 1994, x would be 4. 1996, x would be 6. So really what you're typing in instead of the actual date is the years that have passed.